All right, here is question 3 on the 2019 AP Calculus exam. This was an AB and BC question. And let's see, I'm solving this in real time. I've never read this before, so hopefully I get it all right. Let's see, a continuous function is defined on a closed interval -6 to 5. It looks like it's 2 lines and a semicircle or a quarter circle, which it is. It tells me in the next sentence. Okay, so the circle is centered at 5, 3. We know that the point 3 minus root 5 is on the graph of f. Okay, that's nice of them. If -6 to 5 of f, so -6 to 5 of f is 7, find the value of -6 to -2 of f of x dx. Let's see. So -6 to -2 plus -2 to 5 of f of x dx would equal -6 to 5 of f of x dx. And we know this last piece, -6 to 5 is 7. Let's see if I can figure out -2 to 5. This is my unknown. I'm trying to solve for that. So I'm guessing the area from -2 to 5 is going to be somewhat easy to find. Yep, so -2 to 5, that whole area, so I'm going to kind of draw it right here. So, oh, -2 all the way to 5. Ugh, okay, so -2 to 5. I would screenshot it, but I don't think I'm allowed to do that because I did screenshots a couple of years ago and College Board told me that I wasn't allowed, so, oh, geez, okay. Trying to think how I can do this on here if it makes sense. I'm just going to count the area using geometry. I guess I'll draw it up here. Okay, so we go from -2 to 1, and then we go down there at -1, and then it's a line to 2, 3. And it's going to cross at 1/2. That's 1. Okay, so let's see. That's 1/2. So the area from -2 to 5, I have a 1/2 right there, and that's positive. And then I have a -1/2 here, so that's going to cancel out. And then I have a quarter right here, and that's also negative. I need to make that red, so that's -1/4. And then I have another positive quarter here, so that's going to cancel out. And then right here, I have an area of 1. I need to put my plus quarter. Plus a 1, plus this triangle is an area of 1. And then to get the part under the quarter circle, I'm going to get this area of the fourth of this circle. That would be 1/4 pi r squared. 1/4 pi, and the radius of that circle is 3, so 1/4 pi times 9, so that's 9 pi over 4. This whole rectangle is an area of 9, and so it's going to be plus 9 minus 9 pi over 4. And so the area from -2 to 5 using geometry, let's see, 1/2 minus 1/2 cancels, 1/4 minus 1/4 cancels, then I have 11 minus 9 pi over 4. So 11 minus 9 pi over 4, and then finally I can use geometry, algebra to finish solving this. Yee. Okay, the only annoying part of that is I had to hand draw the graph. So I end up subtracting everything over. I get -6 to -2 of f of x dx is going to be 7 minus 11, which is -4 plus 9 pi over 4, and I am done. Blech. I think I made that a lot worse than I should have. Maybe I should be working these problems before I start recording. All right, number B, evaluate the antiderivative from 3 to 5 of 2f prime of x plus 4 dx. That antiderivative is going to be 2f of x plus 4x. We'll evaluate that from 3 to 5, which will be 2f of 5 plus 20. When you plug in 5 minus 2f of 3 minus 12, So that's 2f of 5 plus, minus 2f of 3 plus 32. And then we'll go to the graph, f of 5. One of them they gave us. F of 5 is 0. Okay, that's nice. 2f of 3, that's the one they gave us, was 3 minus the square root of 5 plus 32. And I'm going to stop there before I hurt myself. If I need to come back and evaluate that for a later question, I will. So there's my answer to B. C, the function g is given by, so let me write this down. So g is negative 2 to x of f of t dt. And I'm going to go ahead and make a note to myself. The derivative of g prime of x is going to be f of x through the fundamental theorem of calculus. Find the absolute maximum value of g on the interval negative 2 to 5. That sounds like an extreme value theorem, so I need to consider endpoints and critical numbers. So my critical numbers are when g prime, which is f, is equal to 0, and f is equal to 0, crap, 3 times, negative 1, 1/2, and then again at 5. But 5 is an endpoint, so I would have tested that one anyway. So now I need to test all of my candidates. I'm going to find the value of g at my left endpoint of negative 2. I'm going to find the value of g at negative 1, the value of g at 1/2, and then the value of g at my other endpoint, which is also a critical number, at 5. So g of negative 2 would be the area from negative 2 to negative 2 of f of x, which would just be 0. G of negative 1 would be the area from negative 2 to negative 1 of f of x. And looking at the graph, negative 2 to negative 1, that's an area of 1/2. G of 1/2 is negative 2 to 1/2 of f of x dx. And so I know from negative 2 to negative 1, that's positive 1/2. Negative 2 to 0 is negative 1/2. And then 0 to 1/2 looks like it's negative 1/4, which gives me an overall area of negative 1/4. And then g of 5 is the area from negative 2 to 5 of f of x, which is all that ugly garbage I did a long time ago up in part A, I believe. So negative 2 to 5, I figured was 11 minus 9 pi over 4, and you are allowed to import that answer. So if I did make a mistake in part A, because I'm importing that work from part A into part D, did I say 9 pi over 4? Is that what it was? Yeah. I would still get credit for that. So now we are looking for the absolute maximum value, which means the y coordinate. It looks like, so 9 times pi is 27. Oh my gosh, this is a non-calculator question, isn't it? So 9 pi over 4, that's about 30 over 4, I'm guessing. That's going to be greater than 1/2. I know that. Okay, that's all I needed to do was compare this value to 1/2 to see which one was the most positive. You could also look at the area. There's a lot more positive area from 1/2 to 5 than there is. There's enough positive area from 1/2 to 5 to overcome whatever happens before 1/2. This is my absolute maximum, and so I would just say the absolute max value is 11 minus 9 pi over 4, and I am now done with, there, make that obvious, there. I'm now done with part C, and let's see, part D, let me scroll down. A limit, okay. Find the limit as x approaches 1. This is probably going to end up being a L'Hopital problem. 10 to the x minus 3 f prime of x over f of x minus the arctan of x. Holy cow. Okay. Maybe it's not. That's 10 minus 3 f prime of 1 over f of 1 minus the inverse tangent of 1. Okay, let's look at the graph here. And so I'm looking at f, and so 10 to the first is 10, f prime of 1 is the slope of the function f at 1, which is 2. Okay, this is not indeterminate. F of 1 is 1 minus the inverse tangent of 1 is pi over 4. And I guess I'll clean that up a little bit. So 10 minus 6 is 4 over 1 minus pi over 4, and we're done. Okay. Did I do that right? I wasn't expecting it to be that easy. I thought we were going to have to do L'Hopital's rule. Okay, I guess that's right. I don't feel like going back and double checking. Hopefully it is.